All right, let's dive in. Today we're looking at 3D waves, and we've got some really cool resources from open educational resources. Open source physics at Singapore. They've built this JavaScript simulation, and it lets you watch how math functions actually ripple and change over time. We're going to unpack all that.
Yeah, it's really about bringing these numbers to life, instead of just like crunching numbers, we can actually see them in 3 dimensions. And this simulation, it's called plotter z equals fxyt 3D waves. And you can even embed it on your own website.
So we can actually see these waves, but how does that help us understand the underlying math?
So think of it like this. The simulation takes those complex formulas and turns them into something we can see, like visuals. Every peak, every trough, every curve, it all matches up to a specific math function. It's like a visual dictionary for wave equations.
I like that, yeah. And it looks like they've included a bunch of
Mhm.
pre-programmed wave functions.
Yes, 15 to choose from. You've got your basic plane waves, but then it gets more interesting, like radial wave outward or interference concurrent F1 plus F2, which sounds pretty wild.
Yeah, that sounds like some epic wave battle is about to happen on my screen. But beyond these presets, the source mentions that we can actually create
Mm.
our own custom waves
Yeah.
using a formula editor. That's got to open up some crazy
Oh,
possibilities.
yeah, for sure. This simulation's all about experimenting, and
Yeah.
exploring the connection between the math and what you actually see happening.
So we're not just stuck watching these preset waves. We've got tools to actually manipulate them. The source material calls it a wave-making toolkit. What is that all about?
It's like a set of controls that let you fine-tune how the wave looks and how it behaves. And these parameters, A, B, C, and P, they each do something specific to the wave.
Okay, let's break it down one by one. What's A do?
So A controls the amplitude, basically how tall the wave is. Higher A. Taller wave, more dramatic. Lower A, more subtle.
Okay, so if I want a tsunami, gotta crank up that A. What about B?
D is all about frequency, how many peaks and troughs you get in a certain space. Higher B. More peaks and troughs packed together, faster, more energetic wave.
Got it. So A is like the power,
Yeah.
and B is like the speed dial, and C does that control the direct.
Got it. For certain waves, C lets you make them travel diagonally.
Oh, now we're talking. I can already see myself creating some weird wave patterns.
All right.
Last one. What does P do?
P is a little more subtle. Yeah, it affects the wave speed, but
Yeah.
more importantly, it controls how smooth the animation looks. Higher P, smooth gliding motion. Lower P, more choppy and jerky.
So P is like the animation frame rate. That's pretty impressive control. I'm getting the feeling that this is more than just a wave generator. It's like a tool to really explore how waves work.
Exactly. And there are even more ways to change how you see it. You can rotate the whole 3D model with your mouse, zoom in and out. It's like flying through this wave-filled world.
Sounds immersive. The source material also mentions some experiments to try. What stood out to you?
Well, experiment 1 is all about just playing around, getting used to seeing things in 3D. Then there's experiment 4. You get to mess with those parameters we talked about, A, B, C, P, and you see how it changes the wave.
Like instant feedback, I like it.
Yeah.
And I saw experiment 10, which sounds like a real challenge. You have to recreate a wave from real life using the formula editor.
Now that's where it gets interesting. You got to use everything you've learned about waves and math to make something specific happen. It's like the ultimate wave test.
This is all sounding really cool, but I'm also curious about those deeper concepts the source mentioned. What's lurking beneath the surface of this seemingly simple simulation?
Well, for starters, the simulation uses something called phase modulation to make it look like the waves are moving.
Wait a minute, the waves aren't actually moving, it's an illusion.
Kind of, yeah. Real waves, they move energy.
Yeah.
But in this simulation, it's just the visual that's changing over time to look like motion.
That's blowing my mind.
Yeah.
Makes you think about what's actually real, even in a digital world.
Mm.
What other hidden complexities are we missing?
Another big one is interference patterns. That's what happens when multiple waves collide. You'd think it'd just be a mess, but you actually get these predictable patterns. Some of them are really beautiful.
So like those rogue waves,
Yeah,
the ones that seem to come out of nowhere, those are actually predictable.
exactly. It all comes down to wave interaction. This simulation lets us see those interactions and understand how something that seems random can actually come from simpler wave patterns.
So even the craziest wave patterns, we can break them down and understand them. Through physics, this is awesome. We've gone from playing with a cool visual tool to uncovering some pretty fundamental wave behavior. It makes you wonder, what other real-world things can we understand better by looking at them through this lens of simulated waves?
That's a great question, and one we'll be exploring further. as we dive deeper into this fascinating simulation. Are you ready to see how this virtual wave world connects to the physical world around us?
I am hooked. Let's do it. Okay, so how do we connect this virtual wave world to, like, the real world?
Well, I mean, think about it. We are surrounded by waves constantly. Light, sound, even the ocean. And the crazy thing is, a lot of them follow the same rules that we're seeing in this simulation.
So even though the simulation uses that illusion for movement, the math behind it is still like real wave behavior.
Exactly. Like, take light, for example. You know how it bends when it goes through water? That's refraction. And it happens because light travels in waves.
Right, like that Pink Floyd album cover with the prism.
Yeah.
But I don't see any prisms in this simulation.
You don't need them. The whole point is light waves change speed when they go from one thing to another, like from air to water. And that change in speed makes the wave bend,
Yeah.
which is what we see as refraction. And the simulation, it helps us actually see that happening.
So even though it's simplified, it's still showing us the core of how light works in the real world.
Exactly. And it's not just light either. Think about sound. Ever notice how it sounds muffled when it goes through a wall? That's because those sound waves are losing energy as they hit the wall. Again, we can visualize this with the simulation.
This is giving me a whole new perspective on waves. It's like seeing the world differently. What
Yes.
about ocean waves, though? Those seem way more chaotic, less predictable.
Oh, for sure. They are more complex. You've got wind, gravity, all these things affecting them. But even then, the basic principles of how waves behave, they still apply. The simulation can help us visualize stuff like wave interference, where multiple waves combine. Sometimes they create bigger waves, sometimes smaller ones.
So those like rogue waves,
Yeah.
the ones that seem to come out of nowhere, they're not totally random.
Not really. It often comes down to what we call constructive interference, where a bunch of waves just happen to line up perfectly, and their energy combines, creating this monster wave. And with the simulation, we can actually see how that happens, how something that seems random is actually the result of simpler waves interacting.
So even the most chaotic waves, we can understand them through physics.
Exactly. And we've only talked about a few types of waves. There are seismic waves that travel through the earth during earthquakes, radio waves carrying information over huge distances, and even gravitational waves, which are ripples in space-time itself.
Wow. I can't believe this simple simulation can help us understand so many different things.
It all comes back to the power of visualization. This tool lets us see things we normally couldn't and understand the incredible dance of waves that shapes our world.
It's definitely changed the way I think about waves. It's not just about the math anymore, it's about real world stuff.
Yeah, and speaking of real world stuff, we've talked a lot about the technical side, but what about the experience of using the simulation? How are you feeling about it so far?
Honestly, I'm having a blast. The interface is so easy to use. You don't need to be a math genius to appreciate how cool these 3D waves look. And the control you have, being able to rotate and zoom, it's really immersive.
I agree. That camera inspector tool is pretty amazing. You can really fine-tune the perspective. It's like you're a filmmaker directing a wave symphony.
For sure. But I think my favorite thing has got to be that formula editor. Being able to make your own waves and see them come to life. It's just magical.
Yeah, it's a great way to bridge the gap between like the abstract math
Yeah.
and the visual result. You can literally see how changing the formula changes the wave itself.
I'm already thinking of some crazy wave patterns to create.
Yeah.
But before we get too carried away making waves, I think it's time to wrap up this part of our deep dive.
Agreed, but I can't help but feel like there's so much more to explore with this. The possibilities are pretty much endless.
You're right, the possibilities do seem endless. I'm already thinking about all the different fields where this could be a game changer.
Oh, absolutely. Way beyond the classroom even. Like, imagine architects using this to design concert halls. They could model the acoustics, make sure the sound quality is perfect, no matter where you're sitting.
Yeah, that's a great example. Or what about engineers using it to design buildings that can withstand earthquakes? They could simulate like seismic waves, hitting different materials, find the most resilient designs.
It could even change how we experience art and music. Imagine, like, turning sound waves into visuals. A symphony of light and motion all sync to the music.
Ooh, a laser light show powered by this simulation. That'd be wild. And we can't forget about research, right? Scientists could use this to model all sorts of complex wave interactions, from fluid dynamics to quantum mechanics even.
It's like a virtual lab for anything wave-related. a playground for discovery and exploration. And it all goes back to that idea, making the invisible visible, helping us understand the forces that shape our world.
And it's not just about understanding, it's about giving people a way to actually experiment with these concepts, make it intuitive, engaging, even fun.
Exactly. It bridges that gap
Mm,
between theory and experience. It takes something that could be intimidating, like math formulas,
mm.
and turns it into something beautiful, something anyone can appreciate.
So, as we wrap up this deep dive, I want to leave our listeners with a little challenge. Think about something in your life, something wave-related that you've always been curious about.
Maybe it's how music makes you feel, or those crazy patterns you see in soap bubbles, or even the power of a giant wave crashing on the shore.
Go check out that Open Educational Resources website. Dive into this 3D wave simulation. See if you can unlock some of those mysteries. You might even discover something completely new.
The world of waves is full of surprises. It's endlessly fascinating.
Thanks for joining us on this deep dive into the world of 3D waves. Until next time, keep exploring, stay curious, and never stop riding that wave of knowledge.